Hi, I'm Brian from Reason Test Prep. This is our third video in our series on the key to a high GMAT or GRE score. And really in this video, we're just going to give another example of how to apply the kinds of things that we were talking about in the first and second videos. If you haven't seen those videos, especially the first one, it'd probably be a good idea to go back and watch that first. Just because we lay out some kind of general principles. I'll repeat some of them here, but probably be best to at least watch that first video. And so, okay, so, if you haven't watched those, what is the key to a high GMAT or GRE score? It's understanding that the GMAT and the GRE are tests of quantitative and verbal reasoning with a stress on the word reasoning. So, I'll repeat something I said in those videos as well. Content mastery is important, but quantitative and verbal reasoning are more important, and you can't achieve a top score without them. So yes, you do need to learn your rules and formulas and things like that. But knowing all that stuff perfectly is not going to get you to a high score. And often you could not know a lot of that stuff and get a top score if you are applying really great quantitative and verbal reasoning. So so anyway, we have a question here, another question, and I'm going to walk through it if you want to pause the video and think about it for a second. But most people look at this question so first of all, actually, quick side note. This is a GMAT question. It's a pretty hard GMAT. Well, objectively, it's a hard GMAT question. It's not that hard once you understand how to do it, and if you're being a good problem solver. But objectively, it's a hard question. And on the GRE, it would be a very hard question as well. If you're a GRE student, you might be tempted to be like, oh, well, I could probably just do this on the calculator. Don't cheat and use the calculator. If this were a GRE question, the numbers would be bigger so that you couldn't use the calculator. So, don't use the calculator. And in general, we believe in using GMAT questions to prepare people for, at least GMAT quant questions to prepare people for the GRE. That could be a whole video in and of itself. But if you're going to do that, then when you're doing GMAT questions, you shouldn't be using a calculator because these questions are written to be done without a calculator. So it's a great question. And again, you could see something very similar on the GRE. It's just probably the numbers would be bigger so that you couldn't actually use the calculator, since that would a little bit defeat the purpose of the question. So, okay, so most people look at this question and are just completely thrown. They're like, oh, this looks impossible. This looks crazy. It's just so much going on. It's very hard to understand what to do. I think there's a couple principles here. I mean, one is, you obviously want to take stock of what they're giving you and what they're asking for. And in terms of what they're giving you, right, like the answer choices are part of what they're giving you. So, that's a fundamental principle, is that you always want to look at the answer choices and think about what clues they might give you about how to approach the question. So in this question, it's significant that all the answers have this 6,725,601, just like what they're giving you, here. So clearly there's going to be some way to use this piece to answer the question, right? That's one realization you need to have. A second thing is understanding that this equation here looks a little bit like this equation here, right? You have this like series of exponents, basically, kind of looking a little bit like what's happening there. So clearly there's something going on between those two equations, and some connection to the form that the answers are taking, right? Now, even noticing that, people still are just like, look, I don't know how to get this started, right? Well, so I'm going to repeat something I actually said in the previous video, which is actually a couple things. One I said, one I don't think I said exactly. But one is, again, doing things in a more tangible or concrete way is often easier than doing them in a more abstract or conceptual way. So, I think the idea would be to try to get in here and start kind of putting in some numbers, right? And that's maybe a kind of a second point, is that making things more tangible, more familiar, more intuitive often opens a window into a deeper understanding of what's really happening in the question. So it's not just like it's like a shortcut or something like that. It's really, the truth is that people often can see things when they're using numbers, or when things are in a more familiar, intuitive context than when they're in an abstract and unfamiliar context, right? So often the act of making things more tangible all of a sudden opens this window into that deeper understanding that you didn't have in the abstract and in the more conceptual space that you're in. So here you know, it'd be great to try to make some sense of what this formula really is doing and how it's going to relate to this, right? So again, you could still have like kind of no idea of really where this is going to lead. You're just sort of playing with it at this point, right? So, you know, this whole equation here has, you know, base 7 raised to powers all the way up to 7 to the 8th. And this is, you know, 7 to the 9th. That's what they're asking for, right? So it'd be a good bet that if you're going to use this formula, plugging in 7 as your base would be a good idea, right? Now, what about your exponent? Well, I'd say either, you know, an 8, you know, given that that's what this equation goes up to, or a 9, since that's what the question's asking for. And maybe plug that in as your value of n, right? And just sort of see what happens. Again, you might not have any idea where this is going to go yet, but this is sort of quantitative reasoning, basically. So given that the question's asking for 7 to the 9th, probably a better idea to actually just plug in, you know, n equals 9, essentially, and, you know, x equals 7, and just see what happens. And when you do that, I'm just going to write it right over this. You're going to get, you know, this will become a 7. This becomes a 9. So you have 7 to the 9th minus 1 over 7 minus 1 equals, and then this is going to be a 7, and this is going to be an 8. This is going to be a 7, and this is going to be a 7, you know, and then 7 squared right there. Let me just cross it out and put it there. That's 7 squared, you know, 7, and then plus 1. Well, oh my God. That looks exactly like what they just gave us here, right? Here's 7 to the 8th, 7 to the 7th, 7 to, you know, all the way down to 1. So, I mean, clearly then we know that this equals this, basically. And then look at this. On the left side, we have 7 to the 9th minus 1 over basically 6, right? So now we even have it kind of equaling something like what they're asking for. Now, that, again, you don't have to quite fully know that that's going to happen, but that's quantitative reasoning. That is just sort of playing with it a little bit, making it more tangible, more familiar, and seeing if that leads anywhere. And indeed, it almost leads directly to the answer. It's pretty easy from this point because now you have 7 to the 9th minus 1 over 6 equals, again, this is 7 to the 8th all the way down to 1. That's this, so that's that. So you have that equals 6,725,601, right? And then now it's like literally just basic algebra. So now we have to multiply both sides by 6 to clear that out, right? That'll cancel there, and you'll get, you know, this times 6 over here. And then, you know, we have 7 to the 9th minus 1. So now we're going to add 1 to both sides. Let me just rewrite it. 7 to the 9th minus 1 equals 6 times 6,725,601. Right now, just add 1 to both sides. Bring that over here. That's going to get rid of that. And that's it. So 7 to the 9th equals basically choice A, right? So anyway, this is a great example. It's on the surface, it looks impossible. And yet the math that you need to be able to get this right is really very, very basic. It's basic algebra. And so this is just a good example of a question that really defies, it's going to, you know, prevent someone who is just doing kind of content study. It's going to prevent someone like that from, you know, getting a question like this right and getting a high score. And yet someone who has not done a lot of study at all, but is applying good quantitative reasoning is going to get this question right. So anyway, just one more example to help illustrate this idea of kind of leaning into reasoning. So, you know, again, this is something I said in the other videos as well, but you want to align yourself with what the GMAT and the GRE are meant to measure and reward, and that is reasoning, right? And so, yeah, you want to really lean into reasoning, lean into problem solving, and lean away from the simple application of content that you have memorized. And in doing that, you will be aligning yourself with what the test is really designed to measure and reward. So something to really be very deliberate about in your practice. It takes practice. It takes really deliberate practice to try to do that. But that's the key to a high score on both the GMAT and the GRE. Okay, I hope you found this video helpful. If so, please feel free to subscribe. And if you know of anyone else who you think might find it helpful, please feel free to share it with them. Thanks again for watching.